Number 4, we have a group frequency table giving information about the ages of 200 elephants. It says, draw a cumulative frequency graph to represent this data. Now, I'm sure you were told this in lesson, but if not, if you were ever wondering what all the squirrels on the front of the packs were for, you might have noticed that that squirrel only has one arm. He only has a right arm. I'm going to do a dreadful job of drawing a squirrel here. So he only has a right arm. And that's because this is Cedric Frederick. And Cedric Frederick is here to help you remember cumulative frequency, because Cedric Frederick begins CF. And so does cumulative frequency. That's a dreadful squirrel. Do squirrels have noses? Okay, so cumulative frequency means to accumulate the frequency. That's literally what it means. So if we fill in this cumulative frequency, this handy little column that somebody's left here, let's label it. Okay, if we just look at this row, we've only got 55 in the frequency. If we include the row below, we've now got 115. So we've seen 115 elephants up to age 20. If we then go from 0 to 30, we've seen 155 elephants. From 0 all the way up to 40, we're now including these ones, so that takes us to 177. And then up to 50, we've got 190 elephants. And then if we include the final 10, that takes us to 200 elephants. And it's always good to check with the question, because it often says in the question how many things you're dealing with. So it's good that it adds up to 200. Okay, now here's what Cedric Frederick has to do with things. He only has a right arm, and that's because he's a war veteran, and he lost his left arm in a battle. And the fact that he only has a right arm means that he can only collect up all his nuts and things with his right hand. And you need to plot a cumulative frequency graph using the right hand values for age, the upper class boundaries all the time, plotted against cumulative frequency. Okay, so if we have a look what that would look like, we need to plot age of 10 against a cumulative frequency of 55. So age 10 up to 55. Now our scale here is going up 60, 70, 80, 90, 100. So each of these small squares is 5. So there is 55. Okay. Next one, we're plotting 20 years against 115. So up to 115, that'll be there. Now 30 against 155. That's there. 40 against 177. So 160 will be there, 170 will be there, 175. 177 is somewhere in that next box. 50 against 190. This line's quite hard to see. There, I believe. And the last one is 60 against 200. Okay, and you should join a cumulative frequency with a smooth curve going through all the points. Now that's going to be very hard for me to draw accurately using this. I'll do my best. Okay, whoops. There we go, not a bad effort. Okay, good enough to show what we're going to do anyway. Right. The next part says, use the graph to find an estimate for the number of elephants with ages of more than 26 years. So we need to draw a line from 26 years upwards until it hits our cumulative frequency curve. We then need to go along horizontally until it touches the vertical axis and read off what we get. Okay. So here I've got 145. Okay, but in my other model solutions I got 140. It just depends on what your line looks like. In fact, it probably should be 140 because this line doesn't look like it's going through this point here. but this will be enough to show how to do the question. We need to find an estimate for the number of elephants with ages of more than 26 years. So that's everything over here we're talking about to the right of 26 years, and therefore everything above 145 elephants. So if we find out what 200 elephants minus 145 gives, that leaves us with 55 elephants. In other words, this stretch of line here is representing 55 of the elephants. As I said, you might have a slightly different answer. You might have 60 or 50. You should be near there